get it. I just hate Max.
Steep learning curve. That's why we
Very
call it.
steep. It is also like I feel like there's, in my opinion, not as deep, but more as, but like I think that other programs like Touch Designer, for example, if you want to accomplish something that like you would do in Max, I feel like it's a little more straightforward. And then if you wanted to make plugins, because I know some of my friends who took this class and recommended it to me were saying they like Max for making plugins, but like you can write a plugin in C++
Yeah.
and it distribute it yourself. And I feel like that's also more straightforward. So Max feels like, I
I'd say
guess,
Max is just like a, very steep learning curve, but once you learn it, they can actually also do a lot of things.
but what is Max like the best at?
Best what?
Like Touch Designer, I would say is the best for real-time graphics and audio reactivity. C++
It's
is like the best widely distributed programming language. It runs on everything. I guess like what is Max's like specialty?
Max is basically audio, more audio centric. It's just like Touch Designer for audio. And so you can actually do a lot more things than we cover in class. It's that, these granular synthesis thing, additive synthesis, FN synth, and it can also just seamlessly connect it to Ableton. And that's part of the reason why Max has been impactful in the field. So I guess if you're coming from Torch Designer plus C++ and Juice, then you sort of you already know how Macs are port into these things. Yeah. It's like Macs in the end still write some C code, juice, to get real-time audio. So if you do know how to write that, then why should you do Macs? But if you don't know how to do C, then Macs is a way that you are just scrapping these sounds, and these just like, analog synthesizers where you are grabbing those, these cables and patch it to different places. So I guess that's just a way that, without looking into, you know, I guess this is also much nicer, for musicians who never code, than it's like looking at this, it doesn't look like a code, right? And you just feel like you are patching something, and you do know how to do it if you are from the computer music, um, background. So I guess that's the point, is like, if you do know how to write in Juice, then, all these, keyboard, whatever DAW are written in that. But it's never easy to get started with those.
Yeah.
Yeah. And Touch Designer is more the visual part. But, also think about like, why should we learn processing if you don't know how to know C and Java? But again, it's like for people who never do it, it's sort of like think about C++ versus Python as your first language.
Yeah.
And from my experience, I learned C++ and then I stopped coding because I was like, coding this and it's not fun at all. But once you know that, well, coding is much high level, it's not about those details, but more how you design, then it become more fun. And I guess these are why these high level programming exists, coexist with those very low level programming language, because it's a different purpose. Yeah. But also sometimes you can think of, think a level up. You don't need to work on those, Yeah. So let's take a look how we can do preset. So as you might already play with that, is that if you do a preset here, that doesn't really work. Let's take a look. Preset. So, if we do have a preset here and then you want to turn something, then likely it won't work. Say, let's just do a duration here. VDSR, attack. So say we save 100 to the preset, and now we have 1,000 to the second preset. So now you can click on those. But what you will notice is that these doesn't really work. I'll create it on my laptop output because I couldn't get speaker setup somehow.
Presets. Yeah.
These things.
Using the-
What do you mean?
Oh,
So here I'm doing preset in this file. And outside I would just do a U menu as I send you in that thing. But basically what we were trying to do is that, well, this preset only affect when you look at this, my sound is like 1. So this is actually the first instance of that. So when you click this preset, it actually only applied to one of those. So if you played it several times, so this is the one that with the higher attack. So, 10 of those, you only apply to one of those. So now the idea is that can you do something in this, parent file so that you send this information to control each of those presets. So if you look at the preset, if you look at its input at the top, you can actually trigger that. So that's what we want to do. So now, ideally, what we want to do is that, well, this unpack will get 3 inputs now, and this input will be used to control the things. So that's essentially what we want to do. So now what we want to send to this poly thing will be one more thing. That will be the preset output. So technically what you want to do is something like this. So now you select the preset. We can get a message to see what this preset get us. So, when I select preset 1, it actually show 0. Preset 2, it will show 1. Preset 3, you will say 2. So now we are sending additional information to the thing. So you can see it here that I don't think it will work for now because I didn't save it. So should I save it? I guess let me save a copy of that. So if I do my sound 2, and then here, let me change this to my sound 2. Hopefully when I click it, now I have that one. So now if I send preset 1 and the distance send to this, why? Let me see. Did I mess up something? Pack 000. So I send the serve preset outputs, which is 0 to poly. So it should show up here. But somehow it isn't. So what's going on? Maybe I just need to make more of those. Nope. Let me see what's going on. This is my sound 2. Let me click it again. Oh, because 0. So when I press this several times, you will see that it actually sent this 1 to this hint. So what's going on here is that, this preset, when you control these, this is 1, 2, 3, 4, 5. But here preset output is like 0, 1, 2. So technically you want to add 1 to that. So you want an object that's like +1 to this thing. So technically you want to have this preset +1. This thing. So this is technically what you want. So when you click preset 1, you should get 1. Preset 2, you should get 2. Preset 3, you should get 3. So now what happened is that now you can basically do your preset. So preset 1, and this is like the shorter attack. And when you click it for 10 times, finally it back to the one that you are doing, then it will be preset 1. Now you click preset 2, then you click it, then these preset 2 information will be sent to here to enable the preset 2. So this is how you can do it to do the preset. So if you do want to do it, but I mean, it's optional, given that it's a bit tricky. But basically that's what you need for homework 6 to get it right. So preset in these things doesn't really work. Somehow I feel like last year is working for me, but somehow it's no longer working. Or my memory distorted. But anyway, this is another way that you can do preset. But now it's a little bit different from preset. Now it's like, well, we still have preset here, just that we need to send the information to control that preset. Cool. Any other questions on homework 6? Awesome. Anything you find confusing in homework 6? I feel like the my sound thing that when you double click, it will open like an instance. And when you double click in the folder, it will open that particular patch, which is a little bit confusing. And there will be 10 of these being created. So that's sort of how you navigate this polyphony thing. So think about it like, well, this is the main patch, and theirs is that file that's specified here. But what this thing does is that open that file 10 times to create 10 synthesizers. And when you double click this, it actually just open one of those. So this is like number 7. So you actually just open one of those files. So when you do something here, if you didn't save it, then it won't be propagated to other files. So, and that's also why when you click this preset here in one of those instances, you only change the sound for that. So what you want to do is that you now do the preset, set the preset number here. You still have the preset set up in this file because you are saving specific, say FN scenes like the filter graph here in these preset, but now you are controlling these effect on something on the master level where you have the parent file to send it to. One more thing about the pack. So you can also see what pack is doing. Basically, now you have 3 information, even 4 or 5, 6, whatever information, you pack them together. Now, in each of these mono things, then you unpack them to get those out. So that's essentially how it works. If you do want to make polyphony work and preset work. Cool. No questions? Cool. Yeah, so not last week, on Monday, we basically look into this drum machine thing. So first we look at this matrix control. Now you should be more familiar than ever on these. But the idea is that you have this get column things that will just query this metric controls to get the outputs. And you can use unpack to get those 4 things. And then you connect to whatever sound you like. But the more interesting thing is that now you want to make it a sequencer. So basically you just bangs every 200 milliseconds, you have a counter 7 so that it will be 0, 1, 2, 3, 4, 5, 6, 7, and then back to 0, 1, 2, 3, 4, 5, 6, 7. And I guess the more interesting part is that now you can actually do sample-based drum machine. The first thing we did is, using MIDI. So, these are MIDI drum numbers. And if you set the channel to 10, then basically you are doing drum sounds. But you can also load the samples. So this buffer thing is basically how you load the file. So this is sort of like the way how you define loop equal read wave, the thing. So you read the waveform and then you put it into loop. So now you can use play tilde loop to play it. And so this could also lead to the sample-based, sample-based drum machine where you basically just use this controls to play each different sounds, where you have like kick hi-hat, kick drum, snare, and rim, or whatever sounds you like. But more interesting since drum sound, where the kick drum is just plain, boring. You could of course do additive synths to make it even more interesting. So you can add 50 and you can add 100, 200, whatever other harmonics, but this is like a plain boring sine wave. But anyway, it sounds okay-ish. And basically what we did is just an envelope. So kick drum is harmonic. But for hi-hat is much more interesting where, we can grab a pink noise and then use this filter. And we also look into how you can change this filter. You can do high pass, low pass, band pass, whatever pass you want to do it. But also modulate with a very short time, then you get that hi-hat sort of like drum machine-like sounds. And you can do different sounds just by changing these things. And these paradigm of synth synthesize is called subtractive synth. But basically the idea is that you grab a noise or you grab some sound. Now you just apply a filter to get a specific part of that sound in that specific frequency range. And you can get a synthesizer on top of that. And it won't sound like the original sounds, but you do have something that you can play around with. Cool. So today we are going to revive our good old processing back. But first thing I want to show is that now we are doing some networking. So to allow, max MSP to talk with processing, what we want to do is to send through the network. So the way how you think about networking is like, well, now I want to send something to somewhere. When you Google search, basically you are sending that prompt to Google search, so to Google. And Google now get that, and then it compute everything and then throw it back to you. So that's how browsers use. And oftentimes, you do like, www.google.com, you are actually going to a certain address that people know where that is. So think about these are just some address. And so, because now we are talking within our laptop, so it's sort of like doing this very funky thing where I am just sending some information to the network and send it to myself. So how that work? That basically is like 127.0.0.1. You will always see these things again and again if you work on more programming stuff that potentially, then this thing is equivalent to localhost. So what this localhost means is that your laptop, whatever machine you are doing. And so whenever you send something to this, immediately you will get it from your laptop. So that's how they work. It's like sudo sending, send it to your network and then network will send it back. So, you send an email to yourself. That's basically what it's doing. So 127.0.1 or localhost is basically how you do it. So, when I'm, developing like a website, I'm doing Jupyter Notebook. Whenever you try to serve something, you want to test it, usually you will send you this link and you can open up on your laptop. Cool. So now what we want to do is then without opening processing for now, that just do two max patch. There's tons of max patch. And we want to see if we can synchronize to max patch. Let me see. Cool. We does see it here now already. So what I'm doing here is that you see that I'm sending something here, and on the other max MSP, I'm receiving something here. So I can send hi, and then it receive that hi. I can send a bang, it receive that bang. I can do the things, and it will receive it immediately. So this is being done with this UDP send. So UDP is a network protocol. Tons of detail on that, but I mean, there are mainly just two protocol. One is UDP, one is TCP. So we don't really need to look into what these are, but the only thing you need to know is that TCP is the secure way that you do handshake. So think about, in this case, we are sending information to myself. So I don't really care about security, and I don't really need to make sure what I'm sending to, because I'm sending to myself. Why should I care? But think about, in real life, when you are doing Zoom call, you want to send someone and establish that connection, or, you are logging on to some, SSH to SS your, server or SSO for you mesh like VPN setup, or you want to log in to do something. Then in that case, TCP is the way to go. Where TCP do a lot of extra thing than UDP is that you have to first handshake. So handshake is like sender will send something to sort of let them know who you are. And then the receiver will check that certificate and then to see whether you are the guy you claim you are. and then you establish that sort of connection. So there is something going on before you can even send something. So you have to sort of like say hi, and then you will say hi, and then now you send something to verify, acknowledge that you get that information. Then now you stop talking, stop chatting. So that's what TCP is doing. You do something to establish that connection. And UDP is different. It's that, well, I just send a request and then you send it back. So the benefit of UDP is that it's much faster, but it's potentially there could be potential loss because you are sending, you're basically dropping Amazon, delivery, and even no one is receiving that package, you are like, who cares? I would just do it. And TCP is that you make sure that someone is there before you send it to that. So that's the difference between UDP and TCP, but TCP would have this extra overhead. So typically when we are thinking about real timeness, then we are doing UDP. Cool. So that's what we can do. So this is like a very basic thing, UDP send. So you are sending something to these things. So now this extra numbers is another complexity, which is the port. So think about, you have this laptop and it's not just, max MSP or, processing using your laptop as the, like a receiver. So you are sending to an address and there are so many different programs. So this port sort of like the, postal code or, mailbox number, basically. So you are sending into a specific mailbox number. So where you are sending, what machine you are sending, and port is which mailbox you are sending to, which person you are sending to on that laptop. So here we set up this 8888. So certain mailbox are already reserved, but there are 8,000 to 10K-ish things are freely usable. So 8,000 to 9,999 usually those are free. So sometimes you launch certain service that will open out a specific port, but in this case, 8888, you can use it. I usually just use that. 4,000 is also fine. 6666 is also fine. But some of those are being reserved. Like 8,000 is the one that Jupyter Notebook use. But anyway, now we have this specific mailbox. So what we need to do here is basically receive something from that mailbox. So now you see what's going on here. I'm sending this information to myself at mailbox at 8888. And now I don't really need to specify where I'm receiving mail. There's only one way I can receive. So I don't need to set up where I'm receiving. I only need to set up which mailbox I'm receiving that message. So this is basically how it works. And you can technically send whatever, stuff that you want to send. So in this case, these are just numbers. Whatever message coming out, it will send it to that and show it up. So it's a very simple thing. So one thing you might note, okay, cool. So one thing you might want to do is that now potentially you may want to send different things all at once. So in this case is that, everything is like sort of like coupled together. It's like, I don't really know what's going on coming to that. This number could be, coming from this slider, but this, number could come in from another slider. So in this case, if you have like two sliders coming in, so how do you know that, when I was doing this, how do I know that from the receiver side, I am doing this red slider? So that's the point where you want to prepend this message. So you can actually look at what the message become here. So basically when I move it, basically it will say blue slider 53. So now the thing is actually, I have 53, then I prepend blue slider. So now blue slider 53, and now I send the message to UDP send. So now, UDP now receive this blue slider 53 thing. And so this route is basically, you will base on the first prefix and route blue slider to the first one, red slider to the second one. So this is sort of like similar to select, where select is, routing input signal flow to different things. a route without tilde or just route, basically grab that prefix and put the number to different places. And so this basically brought us to this open sound control. So these are all not OSC. So these are just the way that you sort of go from UDP, want to send some information, and later you figured out that I do want to know what this control specifically I'm doing. So I want a key value pair, basically. So sort of like JSON files. Cool. So that's basically how we do OSC stuff. I think I do have some information here. Well, I don't. Cool. I guess we can just look at the examples. So the first thing we want to try is going to from max to processing. So let's do it together, I guess. This might take some time. So the first thing you want to do is that first you need to install this OSC open sound control thing in processing. So open up your processing, your good old processing. Kind of miss it. So go to tools, manage tools, libraries, find OSC P5, this one. OSC P5. In libraries, not tools. Libraries. When you click it, it will be tools. Libraries, OSC P5, and click install. Okay. Cool. So that's pretty much all you need to set it up in processing. I mean, Macs already have that. Macs, you have to install another package to visualize it, but Macs originally natively support OSC. So OSC stand for Open Sound Control, but you can think about it as basically doing the thing we just talked about. We want to send an information, something like, well, blue slider 53. And basically you want to send something like this. And so open sound control is just a protocol to specify how you do this using a certain protocol. So what it does is that it go into something like a slash, so sort of like a folder-ish things. So you can do something like blue slider 53, and it will basically send this message through your network, and every program that understand OSC, this protocol will know how to interpret the things. So that's sort of just what OSC does. So once you do that, the way how you import these things is just import OSC dot wildcard. So wildcard will import everything in that things. But technically what you want is this OSC P5 things. So what you want to do is OSC P5 OSC, and then this network address is where you set up this address. So let's do this part first. The value is just initialized to -1 to start something. So this address equal new net address is just to set up that specific address. And this OSCP5 will listen to 8888. So this OSCP5 is listen to something at that mailbox. Cool. Let's get this part first, and then we'll see how do we do that. Oh, good. Okay, so once again, we are thinking about these kind of thing, right? So we are trying to send something, and we want to prepend And OSC is just a way that you specify this parameter in this order-ish like thing. So you can have slider blue, slider red, slider yellow, blah, blah, blah. You could have, not one, not two, not three, control one, control two, control three. It's just a way to specify thing. So what you want to do here is something like this. Cool. So what you want to do is so in your Macs, go to File and this Show Package Manager. And then search online for ODot, this thing, and install that. File, Show Package Manager, Control-Shift-K, and then search online at the right top, ODot, and then click it and install it. It should be installed here. Oh, good. We are getting closer, closer to that. Oh, good. Good. So basically now we have what we need. So first thing, we can try sending something through that. So o.pack is just sending these two messages together. So we can do it this way. Let's see what's going on with this thing. So now if I move the things around, you will see that now this is something that you cannot read, because these are essentially what's being sent to this UDP. This is the open sound control encoded stuff, but technically it's just the same information, just encoded in some way that you don't understand. But anyway, so O.dot will handle those things for me, for us. So O.pack, basically you have two inputs, so you do /x/y, meaning that you have two input coming in and you will pack them together. And the first number will be 198 and 259. So if you do want to show what the thing is, if you do message is something you won't be able to understand or decipher, but you can do o.display. So this thing is called o.display. So new and o.display. So now what you can do is basically grab this and send to o.display. And now if you move it around, you see what essentially this thing is going on. This o.display is also a nice thing is about when you click it, when it's changing, it will show that white dot over there. But this is technically what's being sent. But by the open sound control protocol, what you are sending is technically something starting with X that has the number 95 here. Y has 307 here. So in MaxMSP, Y started at lower, the origin is in lower bottom, unlike in processing at the top left, which is different. But anyway, in this case, this is like 95, 307, and it will send it to it. Are we good for now? You see those? Okay, cool. Now going back to processing. So now we still have this thing at this part. So now in processing, what we were going to do is the things void OSC event. So this thing is basically OSC P5 predetermined things, like a function that basically is sort of like void mouse press, void mouse click. Whenever there is some OSC information coming in, I will do something. So this take into this OSC message, meaning that, well, whenever I get an event that's OSC event, then you can use this OSC message trying to decipher it to do whatever you like. So this is the things that you want to do. So the first thing we can do is to see what we actually get. So when I run it, let's see. So now if I go back to, so now we have like -1 here. And now when I go back to this, when I click on the random place, nothing happened. Okay, let me see what's going on. Did I do something weird? Oh, I'm sending just a number here. Let me see if I can get something from here. Oops. Oh. Well, I think I click on the wrong file. Because now we are sending two numbers. These is just like grabbing one number only. Let's see. Cool. It's opening. So slow. But we can take a look what we are running here. We just want to print these two things. Okay, here we go. Well, this is technically the way how you do it. Well, this is not very easy to look at. Why is it not getting anything? Print, let me see. Oh, it doesn't address already in use. Let me try it again. Let me turn this off and open it up again. I might need to restart my, so you cannot launch two programs listening to the same port at once. Because I was launching something in Max that's listened to that thing. So now there are two programs trying to listen to the same mailbox, and that's what happened. So now let me restart it. Restart this Max. Actually, I think I need to restart my whole Max MSB. Cool. Let me open it up again. And I have the processing at the right. Hopefully this worked this time. Okay, Max is starting up. Cool. Let's go to where we were. So having these things o.pack /x/y, it should send something like this. And now go to processing. Now I click start. Hopefully it will. Cool. Yes, our listening is running. Okay, so we are good now. Finally. So now if I click on the random position, now you see what's going on. OSC message received, address pattern /x, type tag I. So this is essentially what you get from this OSC message. You are sending two OSC message at the same time, /x 95/y 268. But there's additional information that's being sent. It's like what these numbers are. Are they float? Are they integer? Are they float? Are they string or are they numbers? Or are they just text? So in this case, what you're sending is something like this. You have the address pattern /x and the type tag is I. So integer basically. So you are sending two numbers. One started with /x, one started with /y, and their type is an integer. So what you can see here is that I'm just showing the first OSC message. So that's essentially the second number you are getting because that's the second OSS message that you get. So now you're technically actually sending two numbers, but now we only show one of those. And so that's essentially what we want to do next. Where can we sort of like do something similar to previously what we are doing that route these information separately. Cool. So let me pull up the other thing. So similarly, what we are doing, OSC P5, net P5, set up an OSC server, and we have the network address to this particular thing. And so now we start create a new OSC server, listen to mailbox 8888. So one thing about OSC is now actually most people use this way. So the thing is saying that, previously what we are seeing is that when you get an OSC message, do something. But now this case is like, we want to specify that particularly. So whenever I get something starting with /x, we will run this function. So this is basically the routing. So this OSC.plot, meaning that whenever we see /x message, we run this setx. When we see /y message, then we run this setY. And these functions will just do it that way. So, set x, you get some integer as data, and then you save it to x. And if you get y, you set it to height minus data. Because, in processing, in max, y started from 0 to 400, but in processing is the other way around. So you want to do height minus data. But basically now you can sort of do it this way. So now you can actually just point it at the place. Now you can immediately get it on processing. Shall we do it now? I guess the first thing we could try is just to remodel this. So redo this from scratch all the way to here. Cool. Let's do it now to get a sense what's going on. And, homework 7 will sort of be based on something similar. Shouldn't be too tricky. I'm still developing homework 7. I will release it tonight. But the idea I'm thinking is basically you will draw something in processing, like click under the space, and there will be a ball bouncing. And whenever it touches the lower part of it, you will want to make some sound in max MSP. That's it. So technically, you are just grabbing previously what we have, and now you are sending some information to max MSP. That's what we will see next. So now we are sending information from max MSP to processing. And later we will see how we can go from the other side, send information from processing back to MSP. Cool. I don't know how to. Maybe this way. Cool. Right. If you're doing that, when you open processing, likely it will ask you like allow it to access network, then you just click yes. We are safe because we are just doing sending message to yourself, so we are likely safe. Yeah.
Leave the slider on that.
You mean this thing?
Yeah. I guess
It's just one of the slider, rec slider, I think. No, pick slider. PICT slider. Yeah. pick slider. Or you can find it at the slider session here. Not that one. This one. Yes. Here. This one. The last one. So once you get done this, you can sort of rethink what you might do for your final project. This thing is all dot display. But if you're ever wondering how do I get these things, it's just a message. It's not message, it's a comment. And then you can turn it into a bubble when you click on the inspector and go to all. You can make it a bubble, and you can also choose where you're pointing to. Sometimes helpful when you write in comment. This is just a comment. It's a bubble. Oh, you mean you also click it and do this. You mean the range?
Yeah.
So you click it, also inspector here, value at right side, value at top. You can also set it here. No, you cannot say that. So go to inspector, that's the easy way. Yeah. I mean, because we are assuming that process is 400. One thing you can do is that this thing by default will be 127 to 127. It's just everything in max is just like 127 base. So one thing you can also do is that send that 127 to processing, and then you map it to 0, 400 or whatever width and height. So one thing you can do is that if you don't want to do this manually set up, you can do 0 to 127 for X and Y. And then in processing, you just set it into X equal map. I don't know, whatever your data is. You go from 0 to 127 to 0 to width. So this will basically dynamically map this 0 to 127 to whatever width you have. And similarly, Y equal map data. Data is the number you get here. 0, 127. Now the other way around, height, 0. Then you don't necessarily need to do all of these things. Cool. Anyone proceeded? Yeah, I restarting it. Okay, yeah. So you do need to check when you launch processing to see whether you are actually getting something right here. It was sending these on the address. Yeah. So that thing happened whenever one of these file or one of these program like bind it to that. So if you follow the max MSP thing that you are receiving something, then it will open that, claim that port. So you have to restart max, and now you are just sending something. This is a little bit, tricky, but that's how the model works. I mean, cool. You good?
So the homework will be the other way around, but it's.
Yeah, we will also show the other way around.
In the next, it's not too tricky, it's just some art.
I mean, mostly, as you can see, it's like processing is not that well designed for RSC. By Max MSP, basically a lot of things is already pre-programmed. But it's also not the worst, right? It's not too tricky. Always see the plot. And when you want to send a message, it's similar. You always see new OSC message.
Are we just using the receive?
Yes. Yeah. So you're good now?
Yeah.
Okay, cool. Yeah. Good. Okay, cool. That entrance with notes. Yeah, and then you want to do the voice ZX integer data. Almost done. So this part. So you can think about this plot thing as just like a router kind of. Whenever you see /x, it will round this part, setx, this function. Whenever you see /y, it will round setY. So you can imagine you could even send more than that. And based on whatever inputs you get, then you do a specific thing. And once you do these things, now X and Y will set to whatever new value that you have. And this is the, good old processing things you are doing, just showing where that circle is. Just that now this XY is being controlled by the message coming in. So it could be just jumping around or just moving around. Cool. And so the next is basically doing the opposite way around. We know in processing you can do mouse X, mouse Y and get 50, right? To get the circle that you can click and move, or you don't even need to click. But how do you send it back to Max MSP? And I'm mixing anything. Cool. So one thing I want to also show you is that we can actually also compose our message manually. So in this case, we are sort of like just pack these two things. So /x for the first things coming in, the second one coming in. But we can also do something like message in as we are doing that. So o.compose is a message in Max in OSC. So if you do no.compose, it will become this thing where you can basically just write whatever you like. So /x 150 comma oops /y 200. Cool. Why is it showing this things? Oh, missing space. So if we do want to send our message to that, say in this case, then now if I click it, it will actually send that message to control it. So now we can basically just click on this message. So this is just a way so that, you know, you basically have all the equivalent thing in open sound control. So these are basically message. So when you click it, you send the message to UDP send. So that's another way to send OSC control. So in this case, you are composing, you know, you pack /x to this x value, /y to this value, but at the same time, you can also just write this using o.compose. And then once you click it, then you will send that information to processing. And now in the processing, the same idea, you parse it to show the ball. Cool. So now we basically want to see how can we do it the other way around, meaning going from processing back to max. So let me pull that up. So now, you know, actually from the max part, it's much easier. Then now basically you just do, you know, UDP.receive. That's all we need. And we do these things previously similar route, but now we are doing O.route. So now you basically O.route, now you have X and Y, /X and /Y. Then /X will be sent to the first outlet, and /Y will be sent to the second outlet. The third one is like whenever you don't have a match, similar to, you know, route and select. So X will be shown here. So you scale 0, 400, 0, 127, you know, whatever, to have it to a specific number, and you scale it back. This is like how you show these things. So now basically the tricky part will be on the processing side. So let's see how we can do it. So on the processing side, now we want to compose OS's message. So what you can do here is that, well, pretty much these are similar. So you know, import the OSC P5, net P5. So this net P5 thing is just to set up this net address. The only thing we need from that P5 is just setting up this address. So the same thing, we are having my computer. I'm sending something to myself at port 888, and this OSCP5 is bind to that mailbox. So now how do you do it? So whenever your mouse moved, so that's the thing, you know, mouse click, mouse press, key press, key release, whatever. That's, you know, the predefined processing code, right? So whenever your mouse moved, now we want to create a new message. So what it does is just OSC message, X, new OSC message, and this message is for /X. And what you do is just that message X dot add mouse X. This will add this number after this thing. So now this basically get that set up. So /X column mouse X, whatever your mouse X number will be. So likely it's the mouse X. So it could be, say, 100, whatever. And now once you do that, then you just send it OSC.send. So send this message X to that address. And that address where it is just, you know, yourself at mailbox 8888. So that's it. So what we can do now is that, well, we have these things, and now when I move around, it will send that image back, I mean, that number back to OSC. Cool. Wanna try it? That's essentially what we want to do. So homework, not finalized yet, but the idea I'm thinking is just like, now if you click wherever here, you click it and it will drop. And then whenever you hit the button, you want to play some sounds. I try it, it's kind of fun. But that's the idea. Wanna try it? So the upper part is the same. So the initialization is the same, just that now whenever your mouse move, now you want to send that information to max MSV. And here in max MSV, you are doing this UDP receive, listening to this port. Now you want to do all the route /x/y to make it to different outlet. And you can show it at different things. So again, this, pick slider thing is both a visualizer, but also a control. If you plug in something inlet, then it will shows it. If you, use it as a control, then it will send something out from that outlet. No one wants to try it? Cool, that's pretty much it. You're done? Or you just open it?
I mean, I use the zero file. Does the message leak and do it when you go?
Oh, because the processor knows what it is. So it does it for you.
Okay.
So originally, that's why we need this package. Otherwise, if you do want to compose your OSC message, then you have to also specify the data type. But in this case, of course, processing know what this thing is, because mouse X is like a float in this case. So it would just add that to the mod to that message. So that's why we want to use this package. Otherwise, it's a headache.
Just a question for the homework, do we turn in just the my sound, or should we turn in the
whole thing?
The driver too, so both?
Yeah.
And as long as we have
Yeah.
As long as it has 10 voices, we're good.
Yeah. Yeah. I mean,
But
also my sound,
also,
because without my sound, there's no sound. Yeah. So it's a pair. Yeah. Just add it to, I think you can submit as many files as you like on Grayscope. Cool. Anyone succeeded on doing this other than running the class file? Cool. I guess more than this is that this is also not so elegant. So there's actually another version of that, which is more elegant. So let me grab that.
Demo video just be like my phone.
Yeah.
Yeah.
Cool. So the other way to do it is to create an OSC bundle. So previously, what we are seeing is that we just get this message and we send one message at a time. But you can also send a message bundle. But basically, it's just more fun this way, kind of. So you get a message, /x, mouse X, and previously this is a message, and then you send it out /y, mouse Y, and then you send it to your network. I don't know what network look like. I don't know, like a cloud, I guess. And then now what's doing here is that, well, can we sort of like do a package instead of like one single two messages? So you can also create like an OSC bundle. This could be helpful sometimes when you want to package a bunch of things and then send them all together, because these things will have some effects when they are not sent at the same time. Because potentially you are doing additional things, you're doing additional computation, and you want to send them at the end. So you can compose your bundle all together until when you are ready to send it out. And then you send it to, max processing, and max processing is so real time, right? So you don't want to send this things and then do like after a second you process something and then you send another thing, then now there's like real timeness delay. So bundle is nice when you want to have everything sent all together. But pretty much it's the same idea. But also you can also do something like, when mouse click, you can also add just hi. So you can also send something other than just numbers. So in this case, it's like click, it will send a hi, then you can get the output. Let me see what we get here. So when I run it, now we have this additional thing. So it's not only just getting these, so I can click it, it will get a hi and send it to that. So what you see here is that all the route slash clicked, then you will only get something after that. So this is the difference between route and select. And it's the same in, Max MSP. So route will only give you the things after that, the payload. Select will give you everything, including the specifier. So that's the difference between route and select. Cool. That's pretty much it. So now kind of processing and Max is now connected together. But this is also beyond, Max MSP and processing. It's now everything that can talk to network. Now you can sort of connect them together. So, there's a lot of things going on, even in Python, you can send something OSS message. In other languages, C, Java, or, JavaScript on web audio, you can also send something through the network. So now this is network audio. That's everything can be sent to that. You can even send OSC message to some certain keyboard that if they understand OSC message, then potentially you can do something on top of that. Cool. Questions? Not yet, yeah. Once we have the homework, then there'll be a bunch of questions. Yeah, I'm still trying to get homework 7 set up. Anyway, you'll see. It just shouldn't be too tricky. Cool. Homework 6 will be due on Friday. And definitely start thinking about your project. Now you also see the connection, then potentially you have more stuff to work on. And if you also want to explore, Max has the jitter and, built-in for visual outputs. So if you do want to look at those, it's also fine. Processing is, you know how to do it in processing, but at the same time, it's like processing can be limited because it's more low level. A jitter is more high level, then potentially you can do something there. Cheers. See you next Monday then.